So in this video, we're gonna talk about the Fischer esterification reaction. And we have the reaction between acetic acid and butanol, and the other one between propanoic acid and 1-pentanol. So what is Fischer esterification reaction? Well, this is the reaction between a carboxylic acid and an alcohol. We form an ester as a main product and water as a byproduct. Typically, we use acid to catalyze the reaction, and in the reaction today, we use sulfuric acid. For the reaction today, the first one, we have acetic acid react with butanol. We form, in the presence of the sulfuric acid as a catalyst, we form butyl acetate as the ester, the main product, and water as a byproduct. The other reaction is propanoic acid reacts with 1-pentanol. Again, we use sulfuric acid as a catalyst. We form the main product, which is pentyl propanoate, and water as a byproduct. Okay, so let's talk about the reaction mechanism. We have the alcohol in the presence of an acid, and the alcohol will be protonated, and we form a new intermediate with a positive charge on oxygen, and this is the reversible process. The next step, we have the carboxylic acid, and actually we have the R prime for the alcohol. So the next step, we're gonna protonate the carboxylic acid followed by this process, and we end up having a new intermediate with a positive charge on this oxygen of the CO double bond. Next, we have the nucleophilic attack between the alcohol and the intermediate, and we have a new intermediate. And actually we have a positive charge on an oxygen. Well, we need to deprotonate the hydrogen in order to make a neutral intermediate. So we're gonna use the alcohol, and we're gonna attack the hydrogen, break the bond between oxygen and hydrogen, and we're gonna have a new intermediate without the charge. Well, you can see we have two OH groups, so we need to eliminate one in order to make the ester. So again, we're gonna protonate one of these OH group. All right. We take the lone pair of the oxygen, attack the hydrogen, and eventually we have a new intermediate with a positive charge on oxygen. In the other OH group, we have two lone pair on the oxygen. So one lone pair will move back here to form the double bond and kicks off the water. So we're gonna have a new intermediate with just one OH group. So the last step, we need to eliminate the hydrogen of the OH group in order to form the final ester. So we're gonna take the alcohol, and actually we have a positive charge on the oxygen as well. So we take the OH, we do the nucleophilic attack to the hydrogen, break the bond between oxygen and hydrogen, and eventually we end up having a ester as a main product of the Fischer esterification reaction. Let's take a look at the general reaction scheme one more time. So we have the carboxylic acid react with the alcohol. We form the ester as a main product and water as a byproduct in the presence of the sulfuric acid as a catalyst. Well, as you can see, this is a reversible process because we have a two-way arrows here. So this is a two-way reaction. That means the carboxylic acid react with alcohol to form the ester, but at the same time, the ester can react with the water to reform the carboxylic acid and the alcohol. So we never have 100% yield of the ester. The maximum yield is just around 60 to 70%. So how can we improve the yield? How can we get more of the ester? Well, we need to apply the Le Chatelier's principle in the reaction to enhance the yield of the ester. So what is that principle? The principle is a system at equilibrium subjected to a change in terms of concentration, temperature, volume, pressure. The system changes to a new equilibrium to counteract the applied change. All right. So for the Fischer esterification, we need to force the equilibrium to the right. So we need to drive the reaction to the right, right, in order to make more of the ester. So one way we can do that is to use excess amount of the starting material. Okay, so we use excess amount of one reactant. So make sure we just use excess amount of just one reactant. Remember, just one reactant. So usually we base on the price of the starting material. So whichever cheaper, we're gonna use that as an excess reactant. And in our reaction today, we're gonna use carboxylic acid as a excess reactant. All right, so we use the carboxylic acid as an excess reactant. Another way to improve the yield is we remove the product out of the reaction system. So in the Fischer esterification, usually we remove water out of the reaction system. By doing this, then we can drive the reaction to the right in order to make more of the ester.